Good morning, everyone. Welcome to Circuits 1. My name is Amir, and you are Section 3. I have two sections this quarter. You are Section 3. Remember that for your exam and for official purposes. My office is Nethkin 217, second floor, and my office hours are from 8 to 10 every day. If you need to visit me during office hours and you have a class or something, shoot me an email and try to arrange some other time. And my email is there for your reference. My office phone, I usually don't pick up the phone in my office. So everything that's going to be shared with you in this course, including lecture notes, possibly recorded lectures. I'm not exactly sure about that because of the reason that I'm going to discuss with you. But anything that I decide to share with you is going to be through Canvas. So I strongly recommend that you check your Canvas setting. So every time I do something in Canvas, you'll receive an email. Okay? You receive notification in your email because I don't want you to miss anything. Some of them are super important. So please make sure that you receive emails. From this quarter, we have to, instructors, have to make everything that is shared with you online ADA accessible or ADA compliant. That's why I may not be sure about posting recorded videos. So usually in previous quarters, I uploaded my recorded lectures to Google Drive and send you the link to the Google Drive, but I cannot do that anymore. So the alternative is to upload them on YouTube so it can be captioned. The captioned videos are ADA compliant and it can be accessible. So I may choose this method this quarter. I'm gonna let you know if I decide to share the videos on YouTube with you. I'm gonna send you the link on Canvas again, so you can watch the videos with caption and everything. And about my office hours, as I mentioned, I'm pretty fast in responding to emails. So if you have a problem, first of all, when I say fast, I don't mean in a couple of minutes. Sometimes I may respond them in a couple of minutes, but if you have a question about the homework that is due, don't send it to me around 8 or 9 p.m. You're welcome to send it to me, but I do not guarantee that I answer you before the due date, okay? So that is one thing. The objective of this course, the goal that we pursue, is to teach you the basic things about electrical engineering and circuits. DC circuit, AC circuit, transient analysis, and all of these fundamental things about electrical engineering. This is something that I have to say every quarter. The textbook that is used for this course, honestly, I don't know what that is. I cannot say. Without looking at it, I cannot remember what textbook is used. So don't buy it, of course. Every lecture note that is provided to you is going to be enough for that. Of course, you're welcome to purchase it if you want to throw away your money. Joking. If you want to have it, like if you're electrical engineering and you want to just be a geek and do some extra problems in your free time instead of doing something fun, do it. You can click on that link for class attendance and read the policy. I have to do roll calls at the beginning of every lecture, okay? If you're absent, it's not the end of the world for me. But I have to report your absences to university. Especially there is some specific dates, I think 9th meeting, that I have to report how many lectures you've been absent, or you've been constantly absent, or you started attending my classes but stopped at some point, okay? I have to report all of these to university. From my perspective, for your evaluation, I don't care if you're absent, okay? You can just keep up with the lecture notes, with the recorded videos if they are uploaded and everything. But this is my experience that if you are absent, there's a high chance that you do not so good on your exams, okay? So this is my experience. Because you usually feel detached from the course materials, you don't do in-class assignments, you don't ask questions, and you're not asked question, because I ask a lot of questions in class. So I strongly suggest, since it is 10 a.m., you don't have to wake up that soon, attend the classes unless you have something that you can't. And one more thing is that because I start remembering your names as we move throughout the quarter, like personally, I'm a human at the end of the quarter. If I feel that someone needs a push to go to the higher band, I'm allowed to do that. I'm not promising anything, okay? This is an important part. It's being recorded. I'm not promising anything. No curving, no rounding. But I may choose to do so if I feel that a student has been present all lectures, been very active, and for some reason he didn't do very good on one of the exams. I may choose to give him a push that he needs, or she needs, or they need to go to the higher band. So that's another thing. But under no circumstances I will not deduct any point from you if you have been absent throughout the quarter, okay? Whatever you get is going to go to your final grade on workday. You have homework assignments, a lot of them, a painful amount of them. And it's on web work. You're familiar with web work. Now, this is how you should register in web work. There's a link on a module on Canvas that I've created. It's called Web Work Enrollment. It's actually an assignment. You go inside that link, you click on whatever is inside, it will redirect you to web work, and it will automatically sign you up and log you in. The first time has to be like this. After that, every time that you want to visit WebWork, you can go directly to WebWork website from your browser, or just use the link. Okay, but the first time, this is the important part. I think I sent you a notification about that. The first time has to be via Canvas, so you are automatically enrolled. Every homework that is open for you is going to be due one day after the next class meeting. So if I give you a homework today, it's going to be due on Saturday midnight, okay? After that, you have 2 more days of reduced credit period. I'm not exactly sure if it is 20% reduced or 50% reduced. I think I can let you know later. But it's going to be a reduced period. And after that, again, 2 more days after that, you're going to see the answers. If for any reason, you need extra time, okay? By any reason, I mean an acceptable excuse. Let me know and I try to make that happen. What else? Okay, as you're familiar with web work, you only need to enter the final answer to web work to get the credit, and everything is graded on the spot, okay? But I need you to upload your student work, your work, whatever you have done in order to get to the final solution. I need you to upload it to Canvas portal related to that specific homework. I mean, it's obvious. As soon as I publish them, you will see that, for example, homework one student work portal, something like that, okay? And whatever you've done in order to get to the final answer, handwritten, math whatever, I don't care how tidy or how messed up it is, just upload it to that portal. And just as a thank you, you will get 2% bonus on top of the 100 that you have for this process, okay? And it doesn't matter if the solution that you've uploaded to Canvas is wrong or right. I don't care about that. I just need to see what you've done in order to get to the final answer. The main part of your grading, your homework grading is on web work. So the Canvas part is only for some, I'm not sure if you're familiar with ABET. We need that for ABET accreditation, okay? So you don't have to worry if your solution is wrong or right. Just upload it to Canvas to the specific portal that is associated with that specific homework. Am I making sense to everyone? You'll have in-class assignments. In-class assignments are not supposed to be 100% correct. So I'm gonna grade you based on your effort, okay? Even if something is wrong, or you've missed something, or you couldn't do something, as long as you submit something that shows you've tried, you're gonna get full credit for that in-class assignment. Every in-class assignment is uploaded with each lecture before every class meeting. So after my lecture is done, sometimes it takes 30 minutes and my lecture will be done. Sometimes it takes 1 hour and 50 minutes, okay? So if we have time, you are supposed to start working on your in-class assignment in class, okay? Together I mean, you're supposed to do it individually, but of course you can just discuss it, everything that helps you. And I will be in class if you need any questions. So these are very good in understanding the topic that was just taught, okay? Was just discussed. So these are very important. Usually they are much simpler than homework on web work. And they are very good for practicing and just sticking something to your memory on the spot. Every in-class assignment that I give you is going to be due on the next class meeting, okay? I haven't decided on the time. It's probably around either noon or midnight. I haven't decided. I will let you know. If it is late by a couple of hours, it's fine. I usually don't care about a couple of hours of being late. For web work, it's a different story. Everything is automatically graded, so I cannot make an exception for one student among 100 students, okay? So please be aware of the web work due dates. But for in-class assignment, I'm much more flexible. And you also have mini labs. Mini labs are designed to do experiments on the topic that we learned on a specific lectures. I think we have a total of 8 mini labs. Usually after my lecture is done, we do the mini lab. You will need a kit that is provided to you in that project-based learning office at the end of this hallway. After my lecture today is done, please go there and purchase it. I don't exactly remember how much it was the last time. It shouldn't be that expensive. $10. Please don't forget to get it today after the class because we're gonna need it on Friday. Friday is our first mini lab. Now about mini labs, you will do them in groups of probably around 3 or 4. Now the important thing is that you do the mini lab together and you write one report for the whole group, but for submission you have to individually submit them, okay? If one person from each group submitted, the rest of them should submit too. They cannot expect me to find who the group members are and give credit to everyone. So everyone individually have to submit, Okay, does that make sense? You do it together. You can even just write one report and just take a photo of it and submit it 4 times for 4 different students, okay? But remember to submit it individual. The mini labs, if you miss any, or if you couldn't submit the reports, the mini labs aren't due until almost the last day of the quarter. Not exactly the last here, on May 20th, okay? As you can see, after your 3rd exam, there is a mini lab makeup day, which means you'll have a class meeting just devoted to making up the mini labs that you've missed, okay? In case you want to just make them up or just improve your grade. For example, if you're 79 and you just need a little push to get you to 80, and you might consider that. And until the midnight of that day, okay, May 20th, you have time to submit your lab reports, whether it is for mini lab 8 or 1. So they are not due until May 20th midnight, okay? All of them. But I suggest that as soon as you finish them, you submit them so you don't forget it at the end of the quarter. You will have 3 exams. The first one is on a Wednesday, and the next 2 are on a Monday. All of them start at 6 p.m. They are in this building, probably 318. I'm going to make that official, and I'm going to send you an announcement after I'm sure that these rooms are available. The exams are 2 hours from 6 to 8, and we also have a extended time reduced distraction room for students that have a contract with TDS, okay? So if you want accommodation for your exam, please contact TDS as soon as you can, and so I can accommodate you in that other room, which is probably in some other room in ISB. So you don't have to take your exam in TDS. You can take them here, okay? But in another room with which is going to take from 6 to 9 on the same day, just if you need TDS accommodation, please do it as soon as possible. All exams are closed book, closed notes. Remember to purchase a calculator if you don't already have one that is FE approved. And for any reason, if you need rescheduling for your exam, let me know before the exam, okay? I can just give you the exam on some other day. These are the grade ratings. So you have, apart from the 2% bonus, which is bonus, 15% is web work, very important, okay? I don't want you to underestimate it. 15% is a lot, okay? You can change the band. Okay, you can set your maximum score B instead of A. So please don't forget them. It takes a good amount of time to do web work problems, and they are usually much harder than exam problems. So this is sort of a good part because they will prepare you for the exam. In-class assignments, 5%, mini labs, 5%, and each exam is 30%. If you add them, it will be 115%, okay? But the thing is that I will reduce the weighting of your worst exam to 15%, okay? So whatever you do worst on, whatever exam you mess up, okay? I'm going to reduce its weighting to 15%, then it's going to be 100, okay? Very, very important note here at the top. Please don't torture me throughout the quarter with the total score that you see on Canvas. That's a piece of garbage, okay? It doesn't mean anything. I don't know how to remove that. I've tried. I haven't been able to do so. So your final grade will be based on the weightings that I just talked about, okay? So the final or total score that you see on Canvas is not valid in any sort of form of shape, okay? So that's one thing. I said it in a very bold language, but I'm sure I have to send several announcements throughout the quarter because I will receive emails from you that why my score on Canvas is 97, but my final grade is 50. So I have to do it. This is the grading scale, and as I mentioned, there is no promise curving or rounding of grades. That promise is very important. I'm not promising anything, but I may choose to do so. The contents of this syllabus are not supposed to change, okay? I'm not. And I've tried my best to respect that. But sometimes there are some things that, that can happen. And if I decide to change something from the syllabus, I will say it in class and I will send you notifications. I will send you an announcement, okay? So that's it. I strongly recommend that you use any AI that you like for this course, okay? I'm very pro AI. But the thing that I want you to do is to take control yourself, okay? Don't sit on the side and ask ChatGPT or Claude or whatever to do everything for you, for many reasons. First of all, you won't learn anything. Even if you don't care about learning, I'm sure you care about passing. So remember that on the exam, you don't have access to any AI tools. So even if you, I don't know, take a screenshot of your circuit and give it to ChatGPT, there's a high chance that it messes it up, okay? I've seen it, okay? So don't trust it 100%. But you can get ideas, you can discuss it, you can brainstorm. It's very good things. I mean, you cannot ignore AI in today's life. So be responsible. If there's some disaster or some emergency, we're going to continue our course through Canvas and Zoom if the internet is not affected. And so that's it. I talked about accommodation for students with disabilities. If you need any accommodation, please contact the office of TDS as soon as possible. Study the academic honor code. Please register for ENS so you receive a text. If you need counseling services, the link is provided to you. And if you notice any problem with discrimination, these are the contact numbers and emails that you can report to. The last day to drop the course is Friday, May 1st, 2026. So remember that date, and your second exam grade will be published before that date. So you have a good amount of credit to decide on, okay? And if you need any Canvas on Workday help, this is the link. And this is the tentative course schedule. As you can see, these are the exams. And any question about the syllabus? Yes? Pardon me?
None of webworks are open.
Yeah, they are not. No. They're going to be open from your next lecture. You don't have any homework for today's lecture. Okay? Yes?
Those exams are hard dates?
What do you mean?
Like the exam dates are those hard dates, like they're not going to change?
Do you have any, do you want them to change or are you just
no,
asking?
I'm just making sure.
Yes, unless they tell me that there is some exam on that date that is going to affect you. For example, you have a math course exam on the same time, on the same date, then I'm going to change it because I'm a good person. Yeah?
They won't be moved up, that's correct. They don't need pushed back.
Either or,
Okay.
yeah. But I'm going to let you know. Yeah. And one good thing about this is that both of the sections of this course, I'm the instructor, so I can do whatever I want. Okay? So if I see that my students prefer some other day, I can move it. Okay? I don't have to ask someone else's opinion on that. Okay? Except you, I will ask your opinion. Yeah.
Is the third test the final, or they just all three tests?
Oh, that's a good question. I forgot to talk about that. The course is divided in 3 sections. Every section that is evaluated on the exam is going to be thrown away completely. Okay? By completely, I mean direct question, of course. There are some fundamental parts that you have to know in order to move to the next exam. But every exam is just associated with that 1/3 of the quarter. Okay? So they are not comprehensive. Did I answer your question?
Yes.
Any more questions? Okay. About the lectures. This is how I do things. My lectures are handwritten, and there are going to be 2 versions uploaded to Canvas. The first version, I will upload it before coming to class, usually the day before or 2 days before, okay? This is the version that is uploaded to Canvas before every class meeting. It's not complete, meaning that it lacks some parts. The examples are not solved, and you see some missing parts in it. What we're going to do, we're going to complete that together in class, and then after our class is done, I'm going to upload the completed version to Canvas and remove the previous one, okay? So this is what most of the students have been doing throughout the quarters. They print this, bring it to class, and fill it with me in class. Am I making sense to everyone? Okay. So this is the best version that I've found throughout the years. Not very boring for students. They don't have to write everything, and I'm sort of saving their times for important stuff. One more thing, because of ADA accessibility, after my lecture is concluded and done, I will upload an ADA accessible version, okay, for those who need an accessible version. So that's not going to be handwritten, that's going to be typed, like a combination. So if you're comfortable with them, you can access them. Yeah, that's it. Anyone here is using a Samsung tablet? No? Okay. Can you name some electrical elements? What else? Resistors? Capacitors? Inductors? What?
Resistors.
Yes, resistors. So we have 2 resistors.
Transistors.
Batteries, transistors. The simplest,
Cascading switch.
transformers,
Cascading switch.
cascading switch, very high level. Okay. What else? Someone said it. Wire, right? Wire. Okay, so these are all electrical or circuit elements, right? Now, the good thing about this course is that the 99% of the elements that we're dealing with are 2-terminal devices, okay? Because not all of these elements that you just said are 2-terminal devices. For example, transistors are usually 3 or 4-terminal devices. But in this course, we are focused on 2-terminal devices. So first, uh, these elements, whatever they are, resistor, capacitor, inductor, they are entities representing electrical components or electrical quantities. For example, resistors have different behaviors than capacitors and inductors, okay? We're going to represent and model these behaviors with different elements. Now, these elements are two-terminal elements in this course. What do I mean by two-terminal elements? If you look at the generic form of an electrical element, you see that it's a box, it's a rectangle with some label, A, for example. It can be a resistor, it can be a capacitor, it can be an inductor, or whatever that is two-terminal. And you see that it has two-terminal. It means that it can be connected to the rest of the network or circuit or whatever you want to call it via two different terminals, okay? That's the definition of two-terminal elements. Any problems so far? Now, what happens if I connect several of these, two or more of these elements together using wires? I'm creating a network, okay? So electrical network is when two or more circuit elements are interconnected by wires via their terminals. If you look at this, for example, that's a network. Do you see anything strange about this network? Sorry? Do you agree with him? He said, it's not complete. What do you mean?
It doesn't make it close.
It's not closed.
Okay, did I say anything about being closed for electrical network? No, so that's a network. There's nothing wrong with it. Whatever you have in your mind, that's called a circuit, okay? Which is a closed network, okay? This is a network. We don't care if it is closed or open. Just a bunch of elements connected to each other, okay? Now, super important definition. Nodes. This is very important, and I want to try to understand it from the first lecture. Points of interconnection between the circuit elements. So, this is one node. Do you see the red highlighted part? This is one node. This is another node. This, I used red. These are the nodes. And we can assume that this is just some sort of let's label them, label the nodes. So I'm going to call this node 1, node 2, node 3, and node 4. If you still haven't digested what node means, just give me a couple of minutes. So, can you tell me why these 2 points, do you see these 2 points, are considered the same node? Yeah, there isn't any element between them. Or, in, I want to say better terms, they are connected by wires. If 2 points are connected by wires, they are representing the same note. That's a very important thing to remember. So that both of them are the same note, note 1. From literal definition of note, we usually think of note at some points, not a series of points. But because all of these points are connected via wires, by wires, they are considered one note, okay? And why, for example, 1 point on the purple part is not the same note as the one on the red part? They are not connected by wires. There's an element between them. So they are different notes. So for example, if I do this, what's going to happen? Both notes become the same. So note 1 and note 2 are actually right now the same note. They are representing one note, okay? You will see later that finding notes in a circuit is super important in analyzing the circuit, okay? After we define the voltage. So I want you to remember how to determine the nodes in a circuit, and in order to do that, just to make your job much easier, you need to have multiple color highlighters or pens or pencils, whatever you like more, okay? So remember to have them all time, especially on your exam evening, okay? Very important, please take this seriously, because some circuits are quite complicated in appearance, and if you don't have the colors, you won't be able to understand what nodes you have, okay? Or what elements are in series or parallel or whatever. So this is very important to have several colors. Okay, let's find the nodes in this circuit. How many nodes do we have? 4. Do you all agree? Let's highlight them. Red, black, ooh. Okay. And we always label the nodes. You can use numbers or letters, whatever you want. So this is node 1, node 2, node 3, and node 4. Any problem with finding the nodes? No? Okay. Now, I'm guessing you're familiar with series and parallel connection or combination. Now, what is the definition of series combination?
It's like when they're one after another, and there's no alternative route.
Very good. Yeah. Much better than, well, close to perfect, much better than I expect usually on the first day, because students usually stop at the part that one after the other, okay? And that's the source of many problems, because I've seen students considering C and D in series, okay? Because there's one after the other, especially when they are drawn in a way that they are completely aligned, but there is a branch coming out between them, okay, that makes them not series. That's a very important concept to remember. See, most of you understand series, but if the circuit becomes complex, sometimes you forget the textbook definition and then you cannot recognize if they are series or not. So I want you to remember, they should be connected via one of their terminals and there shouldn't be any other branches connected between them. Did that make sense? They should be connected via one of their terminals, or as he put it, one after the other, and there shouldn't be any branch connected to that shared node. For example, which one of these two conditions is violated and preventing us to call DNC in series? Second one, there's a branch coming out between them, right? Do you see that? So can you tell me which elements here are in series? Yes, so A and B and A and C, right? We can generalize this. If A and B are in series and A and C are in series, we can easily say that A and B and C are in series, okay? So that's a generalization. So let me write it here. We can say A and B and C are in series. And the next question you already answered. B and D are connected via one of their terminals. Why are they in series? No, why not? Is it clear enough? There is another branch connected to their shared node. Makes them not in series. I didn't officially define branch, but I'm guessing you know what branch is. Any sort of connection between two nodes we can call branch, okay? Branch definition and recognizing branch in a circuit is not as important as nodes because we will base our analysis on nodes. Super important. How do you define parallel combination or parallel connection? Pardon me? Elements sharing the same nodes. They should share both nodes. If they share only one node, they are not in parallel. For example, are D and C in parallel? Are they or no? Why not? They only share the green node. Do you see now why colors are so useful? In a complicated circuit, you can easily detect the parallel ones by looking at the colors at their ends. For example, D is bound by green and purple, but C is bound by green and black. Okay, so they are not parallel. But which ones are parallel, in fact? D, E, and F. See, they are all bound by green and purple. Purple, pink, whatever that is. Okay? Are B and D parallel? No. Why not? No. They don't share both terminals. Okay, so let's focus on B and D. Are they in series? Are they in parallel? What are they then? Do we have a term for them? No. So why am I saying this? Because I don't want you to think that if two elements are not in series, they must be in parallel. We have pair of elements that can be neither in series nor in parallel. Okay? So remember that. For example, B and D. Okay. How many nodes do we have here? Let's see. One here. One here. One here. Here. And one more. Let's use blue. Okay, so we have 6 nodes. 1, 2, 3, 4, 5, 6. So we have 6 nodes here. Okay. Tell me which elements are in series. A and B and C, right? Which elements are in parallel? H, I, J, right? Again, do you see why colors are important? Without the first time, I mean, consider the first time that you were exposed to electrical engineering concept. Before that, you were familiar with the word parallel, okay? How did you imagine? Right? Not this. Not this. This is not something that you associate. Your brain doesn't associate this with parallel. If you don't use color, if you're not experienced enough, and if you don't use color, you don't see immediately that I and J are in parallel. Because they are not. Geometrically, they are not in parallel. And you may just miss it in a circuit full of elements. Okay? That's why colors help you see them. Yes?
Why isn't E included?
Pardon me?
Why isn't E included with the parallel?
Okay, what's the definition of parallel? Can you just look at your notes and tell me what's the definition of parallel?
When two or more elements share both their terminal.
Both. E is between blue and purple, but H, I, and J are between blue and green. So one of their terminal is not shared with E. Did that make sense? Yeah, E is only sharing the blue terminal with them, not both of them. It's not connected to green. Any problem? Any question? Give me one moment, please. Okay. Let me ask a little more difficult question. What element should I remove from the circuit, or should I replace it with wire in order to make F and D parallel? F and D parallel. Do you all see that? If G is replaced by a wire, which two nodes become the same? 6 and 4. Do you all see that? If I remove G and replace it with a wire, what's going to happen? 6 becomes connected to 4, so they all become one node. Then F and D are going to be between 3 and the unified node of 4 and 6. Makes them parallel. Okay? I'm going to ask you this question. Which element should I remove? What was your name? Yes, yeah.
Yeah.
Hannah, I'm going to ask you this question. Which element should I remove to make your previous statement correct? So E, H, I, and J are all in parallel. Which element should I replace with a wire? Let her answer this.
E.
No.
Wait. What will make them parallel?
We want to make E, H, I, and J parallel, right? Which element should I replace with a piece of wire to make that happen? It's not an easy question, so don't feel bad if you can't answer.
Can you write it? I'm dyslexic, so I need to see the letters on the board.
Oh,
No. Can you write them?
Write down like
Yeah,
H.
write down on the board.
okay. We want to make these parallel. Which element should I remove?
Oh,
F. Do you all see that? If I remove F and replace it by a piece of wire, then all of these become parallel. Okay? Any problem, any question about this? Good. Now, if you remember, we didn't talk about circuits so far. This is the official definition of circuit. So, any electrical network with at least one closed path is called a circuit. So if you can start from some point on a circuit, move around, and then come back to the same point, it's called a closed path. And you can call that a circuit. In mathematical terms, we call that a loop. Okay, that's called a loop. For example, if you move from the black node, go around all the elements, go to the red, then purple, blue, green, pink, and then come back to black, it's a closed path, right? We call the whole thing a loop. Now, we have a much more important definition of a loop, which is called a mesh. Mesh is a loop without any inner loop. There shouldn't be any other loop inside of it. So it can be called a mesh. For example, the one that I just gave you as an example, is that a mesh? No, because it's made of a couple of several meshes, right? For example, if I go from black, red, purple, green, pink, black, is it a mesh? Again, no, it's made of two meshes. How about black, red, purple, pink, black? That's a mesh because there isn't anything else inside of it, okay? That's the smallest loop that you can have. There is no inner loop in it. Exactly like nodes, meshes are very important for circuit analysis. So let me tell you, let me put it this way. We will have two very general circuit analysis method. They are called mesh analysis and nodal analysis. So you can guess the importance of these two. Now, exactly like nodes, we are going to label meshes, okay? With letters, numbers, whatever. But on top of labeling them, we also need to assign a direction for every loop. You may not fully understand why, but we will learn about this as we move throughout our lectures. So we need to assign a direction for meshes. You will see that this is very important. Now, does it matter we consider clockwise or counterclockwise? No, it does not, okay? But for convention and in order to avoid confusion, we are going to use clockwise direction, okay? Always. In this course, always. If you do it the other way, it's not wrong, but I can guarantee you will be confused if you are studying my notes, okay? So please stick to this convention. Use clockwise direction. What do I mean by that? For example, let's find the meshes inside this. Oops. That is one mesh, right? Do you agree with that? The direction is clockwise, okay? One mesh. We can call it the first one, mesh one. What's the next one? This is mesh 2. Look at the direction, and it's a closed path, right? This is the third mesh. And the next one this is the fourth mesh. And finally, this is the fifth one. So how many meshes do we have? 5. How many loops do we have? It's not important for this course, just something that we might be curious about. How many loops? 5? 10? 6? 1? Okay. The number of loops should be at least, it cannot be smaller than 5. Why? Because all meshes are loops, right? So we are sure that it should be larger than 5. So this is how we usually find this. First of all, we have 5 loops already, the meshes. But loops don't have the limitation of no inner loops. So we can go for 2 mesh loops, 3 mesh loops, 4 mesh loops, 5 mesh loops, and so on and so forth, right? So these are only meshes. Here, let's find 2 mesh loops. Does it make sense what it means? 2 mesh loops, okay? One, two, three, four. Next, 3 mesh loops, right? One thing that I want you to know, if it isn't already obvious, is that the shape of the loop that I'm drawing has no importance whatsoever, okay? The only thing that I want to show you is that I'm going around all the elements that are part of that loop or mesh, okay? And then we have 4 mesh loops. Can you tell me how many loops total? 5, 9, 14, right?
Did you not do another loop for like all 5 loops?
15. The whole thing is 1 loop too, right? So we have 15 here. Any question? Yes. Which one? Yes.
So it's just, if we have 5 meshes, it's 5 factorial. So 5 plus 4 plus 3 plus 2 plus 1, that's how many total loops you can have.
No, because sometimes it's not this clean, the circuit. So there isn't any, or let me put it this way. I'm not sure if there is a formula for that. Any question? Okay, please go to that office, get your kit, go home, see you Friday.